Okay, problem number 75 is another one that you really just need to make sure you're doing your drawings correctly. So they give you the free body diagram here. What that looks like to me is that there is a component of tension that's acting vertically and a component of tension that's acting horizontally. Now here's one of the things that you need to process and recognize. In the horizontal, the only thing that's happening is tension. So there's a horizontal component of tension. What that means is there's a net force. And you might be thinking, well, if it's just hanging there, then there should be a constant velocity. But that's the wrong attitude to have. The idea is that there's constantly a force that's being applied to it from the airplane accelerating, and that constant force is able to basically act opposite gravity to get this thing lifted up at an angle. So the force, the actual acceleration, is what makes this pendant pull backwards. If you're going at a constant velocity and you're sitting in a seat, you're not being pushed backwards. It's only when you're accelerating. So back to the drawings. Horizontally, there's tension. Vertically, again, we have that mass times gravity, which is our force of gravity, and we have tension in the y. So being able to write these out takes care of a lot of this problem. Our angle is 25, so this right here is the opposite, which means sine. So our forces in the x are going to be tension times the sine of this angle. In the vertical adjacent, that's our cosine. All right. The pendant is being pushed backwards. The airplane's not taking off yet with respect to vertical as it accelerates for takeoff. So basically, our net forces in the vertical are going to be 0. Gravity is mass times gravity. And then we've got tension cosine theta. I don't think we know our tension force yet. It's some pulling on the string that's a result of the acceleration. What we'll do is we can rework this to make it equal to tension. All right. And I guess that would look something like negative mg divided by cosine theta. Remember, I will plug a negative 9.8 in for g, so this will end up being a positive value. So now we know what tension is. No, we don't have mass. Okay, so we'll go back up here to this equation. So now my net force is going to cause my mass to accelerate, and I know that it's tension times the sine of the angle, but I've also solved for tension down here. So I can just say my mass will accelerate. Again, that's what a net force does. Mg over cosine theta. And I'll just turn this into 9.8 so that we can get some of our numbers in. So I've just plugged in for the tension in the rope. Okay, and I plugged 9.8 in for G. And then the other part is just the sine theta. So here we go. I know what the angle is. I know what the angle is. I'm solving for the acceleration. That's my question mark. And if I have mass on both sides, I can cancel those out. So this is how we're going to solve for acceleration. And then if you're accelerating for something like 18 seconds, you should be able to get a final speed. All right, so that's as far as I'll get for you. Again, you're working the angle of 25 degrees up there. Understanding that picture is the big part of it. All right, good luck.